Good day everyone. Today we're going to discuss about the chapter 3 research methodology. On the first part of the chapter 3, we have there the research design. Research design refer to the overall strategy and analytical approach that you have chosen to integrate all of the components of your study. Research design is broadly divided into two: the qualitative and the quantitative. A qualitative research design describes qualities and characteristics. It can help us in understanding how, why, or what happened behind a certain behavior. There are different types of qualitative research: case study, ethnography, grounded theory, and phenomenology. Allow me to explain them to you one by one. First is the case study. This is used for in-depth understanding of a certain case. A case can be an individual, an organization, a place, or even a phenomena. One of the examples of this is the well-known study of Sigmund Freud, the case study of Little Hans. Second, the ethnography. The study of people in their own environment with the use of different methods such as participants' observation and face-to-face interview. It gives us deeper insights on a particular context, culture, or group. For example, is the observation of indigenous group. Next, the grounded theory. This is a strong, inductive research method for discovering new theories. It attempts to unravel the meaning behind people's interaction, social action, and experiences. For example is the role of gender in academic performance. The researchers can explore the effect of gender stereotyping or gender discrimination to the academic performance of the learners. Lastly, the phenomenology, the study of phenomena. Phenomenology is a type of research that seeks to explain the nature of things with the way people experience them. This is more on a real life and experience. For example, is the study about the student's perception to the STEM learning.
Quantitative research deals in numbers, logic, and an objective stance. Quantitative research focuses on numeric and unchanging data in detail. Convergent reasoning rather than divergent reasoning. The generation of a variety of ideas about a research problem in a spontaneous, free-flowing manner. There are also different types of quantitative research. First, we have the experimental. A research technique called experimental research design looks into the relationship that develops between independent and dependent variables in order to establish a cause and effect relationship. An example of this is the study on the impact of an advertisement. Second, we have the quasi-experimental. Quasi-experimental design attempts to establish a cause and effect relationship by using criteria other than randomization. Example, a memory task with a group of clinically depressed participants compared to a controlled group of non-depressed participants. This example is a common example in psychology. Third, we have the descriptive research. Aims to accurately and systematically describe a population, situation, or phenomenon. It can answer what, where, when, and how questions, but not why questions. An example of this is asking what percentage of Head Start teachers have a bachelor's degree or higher. Lastly, we have the correlational. Correlational aims to describe and measure the degree of association between two or more variables or sets of scores. An example of this is when a researcher tracks colon cancer rates between drinkers and non-drinkers to determine differences in rates between the two groups.
And now, let us look at the different approaches to sampling. At the highest level, there are two approaches to sampling: probability sampling and non-probability sampling. Within each of these, there are a variety of sampling methods which we will explore a little later. Probability sampling involves selecting participants or any other unit of interest on a statistical random basis, which is why it is also called random sampling. In other words, the selection of each individual participants is based on a predetermined process and not the discretion of the researcher. Probability-based sampling methods are most commonly used in quantitative research. In other words, numbers and statistics-based research. Now let us look at the second approach, non-probability sampling. Non-probability sampling, as the name suggests, consists of sampling methods in which participants' selection is not statistically random. In other words, the selection of individual participants is based on the discretion and judgment of the researcher rather than on predetermined process. Non-probability sampling commonly used in qualitative research. To kick things off, we will look at the four parts of probability-based random samplings. Specifically, we will explore simple random sampling, systematic sampling, stratified sampling, and lastly, clustered sampling. First up, we've got simple random sampling. It involves selecting participants in a completely random fashion, where each participant has an equal chance of being selected. For example, you want to select a simple random sample of 1,000 employees of a social media marketing company. You assign a number to every employee in the company database from 1 to 1,000 and use a random number generator to select 100 numbers. And next in line, we have systematic sampling. Systematic sampling is a method that imitates many of the randomization benefits of simple random sampling, but it is slightly easier to conduct. You can use systematic sampling with a list of entire population like you would in simple random sampling. However, unlike with simple random sampling, you can also use this method when you're unable to access a list of your population in advance. For example, all employees of the company are listed in alphabetical order. From the first 10 numbers, you randomly select a starting point number 6. From number 6 onwards, every 10th person on the list is selected. 6, 16, 26, 36, and so on. You end up with a sample of 100 people, and that is systematic sampling. And next, we have stratified sampling. As the name suggests, stratified sampling involves selecting participants randomly, but from certain predefined subgroups that share a common trait. These are called strata. For example, the company has 800 female employees and 200 employees. You want to ensure that the sample reflects the gender balance of the company. So you sort the population in two strata based on gender. Then you use random sampling on each group, selecting 80 women and 20 men, which gives you a representative sample of 100 people. And lastly, let's proceed to cluster sampling. Cluster sampling also involves dividing the population into subgroups, but each subgroup should have similar characteristics to the whole sample. Instead of sampling individual from each subgroup, you randomly select entire subgroups. For example, the company has offices in 10 cities across the country. all with roughly the same number of employees and similar roles, you don't have the capacity to travel to every office to collect your data. So you use random sampling to select 3 offices. These are your cluster. This method is good for dealing with large and dispersed populations. But there are more risks of error in the sample, as there could be substantial differences between clusters. It's difficult to guarantee that the sample clusters are really representative of the whole population. Right now that we have looked at a probability-based sampling method, it is time to explore some non-probability methods, specifically convenience sampling, quota sampling, purposive sampling, or judgment, and lastly, snowball sampling. First up, we have got convenience sampling. A convenience sampling simply includes the individual who happen to be most accessible to the researcher. For example, you are researching opinions about the student support services in your university. So after each of your classes, you ask your fellow students to complete a survey on the topic. This is a convenient way to gather data. But as you only surveyed students taking the same classes as you at the same level, the sample is not representative to all of the students at your university. Next in line, we have quota sampling. It relies on the non-random selection of a predetermined number or proportion of unit. This is called quota. For example, you want to gauge consumer interest in a new produce delivery service in Malasiki. Focus on Jatara preferences. Now, you divide the population into meat eaters, vegetarians, and vegans, drawing a sample of 1,000 people. Since the market wants to cater to all consumers, you set a quota of 200 people for each Jatara group. In this way, all Jatara preferences are equally represented in your research, and you can easily compare this group. Now, you continue recruiting until you reach the quota of 200 participants for each subgroup. And now we have purposive sampling. This is type of sampling also known as judgment sampling. It involves the researcher using their expertise to select a sample that is most useful to the purposes of the research. For example, you want to know more about the opinions and experiences of disabled students at your university. So you purposefully select a number of students with different support needs in order to gather a varied range of data on their experiences with student services. And that is purposive sampling. And lastly, we have snowball sampling. The population is hard to access. A snowball sampling can be used to recruit participants via other participants. For example, you are researching experiences of homelessness in your city. Since there is no list of all homeless people in the city, probability sampling isn't possible. So you meet one person who agrees to participate in the research, and she puts you in contact with other homeless people that she knows in the area, and that is called snowball sampling.
Good morning to each and everyone. I am Shiname M. Espiritu. Let me discuss the local of the study. The local of the study can be written by providing information about the specific region or specific area where the research was conducted. These include details such as the country, city, or specific location where the data collection or analysis took place. Research local is a term that refers to a specified area and or subject that is being studied in a research project. It is also known as the setting of the study. It includes both the laboratory and the field study. Just like, for example, our study entitled Factors Affecting STEM Learners on their Strad Preference and Malasiki Catholic School Incorporated. The local of our study is in Malasiki Catholic School Incorporated.
The study was conducted in a rural community in the Midwest region of the United States. Especially, the research took place in a small town with a population of approximately 5,000 residents. The town is characterized by its agricultural and community with many residents, employee and farming and related industrial. The study site was chosen in representative nature of rural communities in the region, providing the valuable insight into the challenge and opportunity faced by small town population.
Good day everyone! We are going to talk about the respondents of the study. So, sino nga ba sila? The respondents of the study refer to individuals who are involved in a research study. They are the one who provides data or information in response to a specific research question or objectives. So sila yung mga pinipili natin na mag-participate sa mga survey, interviews, or experiments. So yung mga respondents natin, they play an important role in generating the data and contributing to the overall findings of a study. Pinipili natin sila based on a specific criteria that align with the research objective and target population. Since nabanggit natin ang population, ano nga ba ito? So we have population and sample. When we say population, it is the entire group that you want to draw conclusions about. While sample, on the other hand, is the specific group of individuals that you will collect data from. Yung sample is the subset or part of the population. It is a smaller group. Dito natin kukunin yung data sa kadahilan ng masyadong malaki yung population. That's why huhugot tayo ng sample from the population. It is impractical din kasi to survey each member of a population due to lack of time, money, and it takes a lot of effort kung buong population ang isa-survey natin. So, magbigay tayo ng example. Halimbawa na lang na ang population natin is the entire senior high school na may bilang na 700. Masyadong malaki yung 700, kaya huhugot tayo ng sample size. Let's say na ang nakuha nating sample size from 700 ay 250. So, 250 is our sample size. The smaller group is the sample and 700 is the population size. Paano nga ba mag-calculate ng sample size? Tuturuan ko kayo with the use of Sloven's formula. Sloven's formula is commonly used in research, particularly when the population size is too large and the researcher wants a specific level of precision. So the formula is given as follows.
The small n represents the sample size, the big N is the population size, and E is the desired margin of error. 0.05 margin of error is commonly used sa field ng research. It strikes a balance between precision and practicality. It provides a reasonable level of accuracy while keeping the sample size manageable. So, paano ito na-compute? Simple lang po. 100% confidence level minus 95% is equal to 5%. Iko-convert lang natin siya into decimals. Kung maitatanong niyo po, why not 100% confidence level na lang ang gamitin? Kasi even when we purchase a alcohol, 99.99% of bacteria lang yung kaya niyang patayin. So, nasan yung 1%? The reason behind that is in research po, hindi natin maiiwasan ang error. Meron at meron po o maaring magkaroon ng outliers.
Here is an example to calculate a sample size from the population using Sloven's formula. In this example, we will use 95% confidence level with a population size of 1,000.
So we have 1,000 over 1 plus 1,000 multiplied by 0.05 squared is equal to 1,000 over 3.5 equals 285.71. It should be a whole number, so ira-round off natin ito. 286 is our sample size.
So with the use of Sloven's formula, we got 286 sample size from the 1,000 population size.
Here is another example from the study of Ballesteros et al. Entitled Problem Solving Skills in Mathematics of Grade 12 STEM Learners of Malasiki Catholic School Incorporated.
The researcher chose grade 12 STEM learners as the respondents. They used stratified random sampling and used Sloven's formula to calculate the sample size from the population size.
We have here a population distribution. The table shows the number of respondents equally distributed in each section. So, paano po natin ito i-calculate? Di-divide po natin yung population sa room sa population size and imumultiply po ito sa sample size. Let's have the first one. Blessed Carlo Acutis ay mayroong 47. So, 47 divided by 148 multiplied by 108 is equal to 34.29. So we have 34, 38, and 36 number of respondents equally distributed in each section.
That's all. Thank you for listening at sana may natutunan po kayo.
Next is, what is data gathering procedure? Data gathering procedure refer to the methods and techniques used to collect information or data for analysis or research purposes. The procedure can change depending on the resources available, the type of data being collected, and the nature of the study. Common data gathering procedure include surveys, interviews, observations, experiments, and document analysis. Here are the steps in the data gathering procedure. First, define your research objectives. We aim to achieve or understand through the study, providing a clear focus and framework for the research process. These objectives help researchers stay on track and ensure that their efforts contribute meaningfully to their field of study. Second, determine your target audience. Identifying the target audience in research involves defining demographic characteristics such as age, gender, income level, education, and etc. Surveys, interviews, and data analysis can help pinpoint the specific group most likely to be interested in or affected by the research topic. Third, choose your data collection method. Choosing a data collection method depends on various factors such as the type of data needed, resources available, time frame, target population, and research objective. Common methods include surveys, interviews, observations, experiments, and secondary data analysis. Fourth, collect your data. We collect data in research by defining your question, selecting appropriate methods, gathering information from participants or sources, analyzing data, and drawing meaningful conclusions. Fifth, analyze your data. To analyze your data in research, systematically examine, interpret, and draw conclusions from the collected information to address your research questions or hypotheses. Lastly, act on your results. After analyzing the results of your research, take appropriate action by interpreting the findings, drawing conclusions, and considering their implications for further investigation or practical application.
The statistical treatment. Statistical treatment means to apply a statistical formula in your data, and it defines that it summarizes all the statistical formula in research, which means that statistical treatment is an explanation of all the statistical formula in analyzing and interpretation of the data. More likely, we can say that statistical treatment is the summary of all the statistical formula. Also, statistical treatment depends on the statement of the problem or SOP. For further understanding, we can compare the statistical treatment in the review, which, as same as the review, we are remembering and summarizing the data. For example, in the title, Factors Affecting Reading Comprehension in English Language Among Grade 10 Learners of the Malasiki Catholic School Incorporated, the statistical treatment was: the collected data was tailed and interpreted using a statistical method. It generates specifically using the SPSS or Social Packages Social Sciences application. This hypothesis is a presented assumption in terms of the outcome of the study. There are two major hypotheses. First was the null hypothesis, which is negative, which indicate that there is no significant relationship. Next is the alternative. Alternative is positive. It indicates that there's a significant relationship. In terms of the statistical treatment, hypothesis was test. For example of the hypothesis, if the researcher used null hypothesis, it needed to be correlated with the data using the statistical method like SPSS. Percentage. It is used to calculate the percentage of one value to the average and multiply it by 100. The formula of the percentage was percentage equals FB divided by N times 100. For further understanding, percentage it is used to review or compare the results and the progress. For example, of the percentage, if 4 out of 10 of respondents got the 8 score, it means there are 40% of the percentage. Average weighted mean. Average weighted mean is an average computed value by giving different weights to some of the individual values. If all the weighted are equals, then the weighted mean is the same as the arithmetic means. The formula for average weighted mean was AWM is equals to frequency divided by N. It means that average weighted mean it is to identify the average of the data. For example, there are 9 which is 9 plus 9 plus 9 plus 9 plus 9. Those 9 are symbol as the F, which is the frequency, and you should divide it into 5, which is N. It indicates as N, and you would get the average weighted mean of 9.
And now let us proceed to the two types of statistical tools. First is the t-test, and second is the Pearson correlation coefficient, or also known as the Pearson R. Let us now proceed to the t-test. T-test is a statistical test procedure that analyzes whether there is a significant difference between the mean values of two groups. We have three different types of t-tests. First is the one-sample t-test. Second is the independent samples t-test. And third is the paired samples t-test. Before we proceed to the different types of t-tests, let us differentiate the dependent sample and the independent sample. The values in dependent sample are measured repeatedly with the same people. However, in independent sample, the people and the measurements are independent with each other. We use one sample t-test when we want to compare the mean of a sample with a known reference mean. Next is the independent samples t-test. We use the independent samples t-test when we want to compare the means of two independent groups or samples. For example, we would like to compare the effectiveness of two painkillers. So we randomly divided 60 people into two groups. The first group receives the drug A, and the second group receives the drug B. With the help of independent t-test, we can now test whether there is a significant difference in pain relief between the two drugs. Lastly, we have the paired samples t-test. We use the paired samples t-test to compare the means of two dependent groups, having one sample that was measured at two different times. For example, we wanted to know the effectiveness of diet is. And to do that, we are going to weigh the same exact people before and after the diet. And lastly, we have the person correlation coefficient, or also known as the person R. Person R is a statistical measure of the strength and direction of a linear relationship between two variables. Take note that there must be a clear causal relationship in every correlation. Just because there is a correlation, you cannot tell which way the relationship is going. That is why we have the perfect positive correlation and the perfect negative correlation. A value of 1 indicates a perfect positive linear relationship, and negative 1 indicates a perfect negative linear relationship. A value of 0 indicates no linear relationship between variables. A positive correlation exists when large values of one variable go along with large values of the other variable. It means it is directly proportional. For example, the number of hours studying affects the test scores or the exam scores, while in negative correlation exists when large values of one variable go along with small values of the other variables. It is inversely proportional. For example, the number of hours of studying does not affect the test scores or the exam scores. The strength of the correlation can be read in the table.
Likert scale. So when we say Likert scale, it is a rating scale that is used to get the opinions, attitudes, or behavior of the respondents by measuring their preference, degree of agreement and perception, as well as the frequency, quality, importance, and likelihood. So it is common in survey research questionnaires as well as in fields just like marketing, psychology, and other social sciences. The size of a Likert scale may vary. The most common sizes are the 3-point, 4-point, 5-point, and 7-point Likert scale. So it provides possible answers to a statement or questions that allows the respondents to indicate their positive to negative strength of agreement or strength of feeling regarding the question or statement. Just like for this one, my college classes is more demanding than my high school classes. So with the use of this 4-point Likert scale, you can choose whether you are strongly agree, disagree, or strongly disagree. Measurement scales. So when we say measurement, it is the process of assigning value to a variable. On the other hand, a scale is a device or an object used to measure or quantify any event or another object. So when we say measurement scale, it is used to define and categorize variables or numbers. There are 4 levels of scales of measurement, and it is divided into 2, the categorical and the numerical. The lowest level is the nominal. So when we say nominal level, observations can be named without particular order or ranking imposed on the data. In nominal, words, letters, and even numbers are used to classify data. Here, we are only after naming the data and don't include any form of order or ranking. Just like for this example, the sex, we have the male and female. As you can see, we are only naming or categorizing it whether they are male or female. Next is the ordinal level. In ordinal, it describes the ranking or order. The difference or ratio between two rankings may not be always the same. To better understand, let's take a look in this example. It is in order and champion being the highest. The ratio or interval between these is not the same, just like for example the interval between the champion and the first runner-up is 3%. It is not necessary that the interval between the first and second runner-up is also 3%. It can be 2% or 1. Third is the interval. In interval, it indicates an actual amount or numerical. The order and the difference between the variables can be known. Its limitation is it has no true zero. No true zero because the zero is meaningful in a particular set of data. Just like in this sample, the 0 degrees doesn't mean that there's no temperature. There's still negative temperature, just like the negative 15 degrees and so on. Next is the ratio. It has the same properties as the interval level. The order and difference can be described. Additionally, it has a true zero and the ratio between 2 points has a meaning. Just like the interval, it has a numerical value. We can also see the difference, but it has true zero, which means that there's a starting point. Just like in this example, we cannot have a negative mass, right? We have 2 ratio between 80 and 40 kg, which means that 80 kg is 2 times heavier than 40 kg. And the ratio between the 40 kg and the 10 kg is 4, which means that 40 kg is 4 times heavier than 10 kg.
Oops, oops, oops! I know that your brain has been drained in listening in our discussion, so we prepared a simple game entitled Sagutin Mo at Makukuha Mo to spice things up. And we have a simple instruction. We are going to ask a simple question about Chapter 3 lesson, and the one who answer first are going to get a prize. As simple as that. So, for our first question was, friends lang ba talaga?
Are you lonely? Our fingers dancing where they...
Kidding aside, the real question was, it refers to the individual or participant who are involved in research study.
Dahil tama ang sagot mo, may prize ka pagpasok next week at performance ng aming member. So for our second question, what if second option ka lang? Joke lang po. So here's the question. What is the formula of percentage? Dahil tama ang sagot mo, may prize ka pagpasok next week at performance ng aming member.
Feel just like a storm raining on me, girl, you're soaking wet. Ooh, take it right, yeah, I'm gonna lick all night, yeah.
Thank you for listening.